Okay, in this video I'm going to go through how you use the Casio Classwiz Calculator to help you solve probability questions based on the normal distribution. So if you have a question that has that is modelled by the normal distribution, and I've got an example here, this one has a mean of 30 and a variance of 16, then we can use the Casio Classwiz to help us solve probability questions. I've got a few examples here that we're going to work through. First thing you need to do is find the right option from the menu, and this time we're going to choose option 7. It's got a nice little normal distribution curve to help us find it. So we can use the cursor to find the option, or we can just choose number 7. And then we're going to choose, for these questions, we're going to choose number 2, the normal CD, that's the cumulative distribution. For question A here, it's given us 2 bounds. We, for this one, are finding the area between 33.5 and, well, that's going to be further up, isn't it? Because the mean is 30. So if I've got 30 here, I'm going to have 33.5 up to 38.3. So we're trying to find out this little area here. So the lower number is the 33.5, the upper number is 38.3, and notice this is a really important thing to point out, that this is asking for sigma, so the standard deviation, not the variance. So not the 16, it's going to be the square root of 16, which is 4. The mean is 30, and then if we just press enter and enter again, it will tell us the answer to that question. So the answer to A is 0.172 to 3 significant figures. For question B, we need to do something slightly different. This time, we've got 30 in the middle here. It wants the area up to 30, so all of this. So we need to put a really small number in here. What you're meant to do is put in 5 standard deviations away from the mean, but you can just put a really small number like 0 in. These 2 values are still going to be the same as before, but I've now put my 33 in for the question that I've got, and that gives me an answer of 0.773. And then for the last part, it's a greater than or equal to question, so we want 25 or more. Now, because it's a continuous distribution, the fact that this has an or equal to sign and the fact that this one didn't, if it's just a normal distribution, then there is absolutely no difference between these questions. We're still going to put 25 in this case as our lower bound, and we're going to put a really big number in for our upper bound, and that will work out this area. So this one's 0.894. So that's how you would answer those types. So the other type of question you might need to answer are the ones where they give you the area and they ask you for the value. So if we stick with the same distribution we've just been working with, so a mean of 30 and a variance of 16, notice that means that the standard deviation is 4. Then we might be asked to find the value of x that gives us a probability of, say, 60%. So if we have an area of 60%, we need to know what value of x that's going to be. Now we know it's going to be a bit more than 30 because it's a symmetrical distribution, so 30 would split it 50-50. So because it's 60%, we know it's to the right of the 30. We're going to choose option 7 again, but this time we're going to choose the inverse normal, so that's option 3. And we're going to tell them that this is the easiest type of question. We're just going to tell them the area we're dealing with is 60%. Now, the normal distribution and the cumulative distributions always work out less than or equal to. As I said before, it's cumulative, so it doesn't matter if that has an equal to sign or not in. But it will always be a less than question. So if so I'll show you how we deal with a question that's the reverse of that. But let's just cope with this one first. So area is 60%. We've still got the sigma as 4 and the mu as 30 from before, and this will tell me the value of x. So it's telling me that x must have been 31.01 or 31.0 to 3 significant figures. So that's how we would answer that type of question. If I reverse that and say, well, now I want to know what value would give me 60% here, what this value of x is, so I call that x2, we're trying to work out the probability that x is greater than my little x2. We want that probability to be 0.6. But if that probability is 0.6, then this probability in here is going to be 0.4. So we change the question. We are going to work out the probability that it's less than x2 being 0.4. That's their equivalent. Those x2 values are going to be the same. So then we can go back into our menu, choose the probability of 0.4, and we're going to get this time that x2 is 28.99 or 29.0 to 3 significant figures. The third thing we need to think about is when it's a kind of an area in the middle. So if we've got a question like this, and we want that area to be, say, 40%. Now obviously that can slide around, so we're going to need to know one of these values. So if that's, for example, 28, let's say for argument's sake, what will this value be? Let's call that x3. So let's write down what we're calculating. We need the probability of x being between x3 and 28. We need that to be 40%. Well, the first thing we're going to need to do is we're going to need to work out this area on this side. We need to know the probability that x is less than 28. So we'll go into the inverse normal again. Actually, no, we won't. We're going to go into the option 2 because we're putting in a lower bound of 0 and an upper bound of 28. We've still got a mean and a standard deviation of 30 and 4. So that is 0.3085. So that tells me this area here. That's 30.85%, which means in order to work out x3, we know that x3 is going to have a total area of the 40 and the 30.85. So that's 70.85%. So we can now say that we want the value for x3 that gives us an area of 70.85%. So we go back into our inverse normal, choose an area of 70.85. We've still got the mean and the standard deviation in, and if I press enter, that will give me the value of x3.